चिल्ड्रन, तो आज हम नया बिट दैट इज फ्रिक्शन। इट इज द पार्ट ऑफ लॉज ऑफ मोशन। ये लॉज ऑफ मोशन में न्यूटन्स लॉज के साथ फ्रिक्शन को जोड़ करके रोटेशनल मोशन में भी फ्रिक्शन को जोड़ करके एक प्रॉब्लम्स बनते हैं। कॉम्पिटिटिव एग्जाम्स के लिए बहुत ही इंपॉर्टेंट बिट है या फिर इंपॉर्टेंट चैप्टर है ये फ्रिक्शन। तो फ्रिक्शन को समझने के लिए पहली बात एक एक्सपीरियंस, डेली लाइफ का एक एक्सपीरियंस देखेंगे। एक हेवी मास है ऑब्जेक्ट, सपोज ये ग्राउंड पर रखा हुआ है, जब आप उसको पुल करते यू फील दैट समथिंग इज अपोजिंग द मोशन। जब हम खींचते हैं तो कुछ अपोज कर रहा है, जो अपने को अपोजिशन मिलता है, दिस इज कॉल्ड द फ्रिक्शन। तो फ्रिक्शन, दिस इज one that is static friction. Static friction ये है इसको काइनेटिक फ्रिक्शन। काइनेटिक फ्रिक्शन को हम डायनामिक फ्रिक्शन भी बोलते हैं। बॉडी रिमेन्स एट रेस्ट। और काइनेटिक फ्रिक्शन दो तरह के होते हैं। एक होता है स्लाइडिंग फ्रिक्शन, दूसरा है दिस इज रोलिंग फ्रिक्शन। So here we will discuss mostly because this will be dealt in rotational motion and this will be sliding friction we will deal with. So in kinetic friction we will deal with the sliding friction and static friction when the object is at rest and there is no relative motion between the surfaces in contact, right? So we will start with the kinetic friction. First thing, in kinetic friction, body should be in motion, number one. Second thing, this frictional force always opposes the motion, as I said, and even the tendency of motion is being opposed by frictional force. Opposes the motion. Third is kinetic frictional force. Force is constant. Here constant means when there is motion, it doesn't depend on the speed of the object. So whatever frictional force which is opposing along the surface, actually frictional force acts along the surface in contact tangentially. So here I will write frictional force always acts along the tangent to the surfaces in contact. That is called tangential force. Tangential force, right? Fifth, it is denoted by suppose Fk. K represent the kinetic and F represent the frictional force. Frictional force is always proportional to the normal reaction. It is very important. Normal reaction acting on the object, it is proportional to the frictional force. So this can be understood pictorially in different way that I will let you know. Suppose, as I said, this is the mass and this is frictional force. It is a surface in contact. So Fk will act in this direction, opposite, and velocity is in this direction. Suppose certain force 30 Newton is applied, right? Even though it is motion, primary condition that for kinetic friction, body is in motion. That will have to be considered, and at that time whatever frictional force which is opposing the motion, this is denoted by Fk, right? And some force is being applied, so if it is more than the frictional force, then there will be acceleration also in this. Otherwise the F force applied is equal to Fk, then it will go on moving with the constant velocity. If there is no external force, due to this constant force which is opposing the motion, it will retard and finally it will stop. Example you can see, if you are driving the bicycle and in between if you stop pedaling, then what happens? After some time your bicycle stops. Why does it happen? But initially it was having some velocity. शुरू में कुछ velocity से चल रहा था, लेकिन उसके जो टायर है, व्हील सरफेस के कांटेक्ट में है, दोनों के बीच में एक काइनेटिक फ्रिक्शन जो अपोज कर रहा है मोशन वो लगा हुआ है. सो कंसिस्टेंटली दैट इज कांस्टेंट फोर्स एक्टिंग ऑन इट, और फॉरवर्ड फोर्स जीरो हो गया है, पेडलिंग हैज बीन स्टॉप्ड. सो दैट फोर्स इज कंसिस्टेंटली वर्किंग ऑन इट, सो विच इज अपोजिंग द मोशन. तो ग्रेजुअली वेलोसिटी कम होते जाता है, उसमें रिटार्डिंग एक्सेलरेशन रहता है, रिटार्डेशन रहता है, ग्रेजुअली इट कम्स टू रेस्ट. दैट इज द एग्जांपल ऑफ काइनेटिक फ्रिक्शन एक्टिंग ऑन द ऑब्जेक्ट. सो उसमें कुछ न्यूमेरिकल प्रॉब्लम्स बनाएंगे जिससे कंसेप्ट ज्यादा क्लियर हो जाएगा. ठीक है, जैसा कि हमने आपको बताया, kinetic frictional force Fk is directly proportional to the normal reaction acting on the object which is in motion. Therefore, this Fk is equal to some constant that is called mu k into n. This is a constant. Mu k is the constant. It depends on the type of surface. So, this is coefficient of kinetic friction. This is the coefficient of kinetic friction, and this relation we will use very frequently in solving the numerical problems. It is very important. It is called kinetic frictional force. If you are talking about friction, it always opposes the motion or the tendency of motion. Now we will take a few numerical problems. Suppose this is the surface, one mass is kept on this, that is of 8 kg, and kinetic friction, coefficient of kinetic friction is 0.1, isn't it? Suppose there is some force, 40 Newton force is applied on this, isn't it? F force is applied, that is equal to 40 Newton. So what is required first? That is reaction force. Second, then acceleration in the mass. It is assumed that this mass, it is in motion. When it is in motion, then only kinetic friction will be working, and this coefficient of kinetic friction will be used. One thing is there, frictional force is equal to coefficient of kinetic friction into the normal reaction. So first we will make the free body diagram of this, and we will find the normal reaction is equal to 10 meters per second square. So 8g downward, reaction R or normal reaction R or N, either way. So reaction force R is working. So there is no other force working in vertical direction. So therefore R is equal to 8g, right? Coefficient of kinetic friction is given, then we can find the kinetic frictional force Fk, which is opposing, and this force is acting on the mass, opposing force. Therefore R is equal to this. First part is over, acceleration in the mass. So Fk is equal to 1. Third part you can say that is frictional force. Frictional force is also required. What is frictional force? So Fk is equal to mu k into normal reaction R. Fk into mu k, very important relation. This will be very frequently being used. So तो ध्यान में रखना है इसको। एफ के इज इक्वल टू म्यू के इंटू आर, और म्यू के कितना है, दैट इज 0.1 into 8 into 10. R is equal to 8 into 10 I have taken G. So that is how much? 10 is 8 Newton. 8 Newton force is opposing this, and forward force is 40 Newton. Therefore, F net is equal to 40 minus 8, that is 32 Newton. This is F net working on this, and this F net will cause acceleration in this. Therefore, F net is equal to mass into acceleration, that is 32 Newton is equal to, mass is 8 kg and acceleration is A. This implies A is equal to 32 by 8, that is 4 meters per second square, and this with this acceleration this mass will be moving. Concept is clear. Application of the Newton's second law with friction. So Newton's second law and the frictional force is combined to solve this problem. इसका combination हमेशा रहेगा, Newton's laws and frictional force. या रोटेशनल मोशन ले लो, जैसा हमने शुरू में बताया, इसका कॉम्बिनेशन से ही एग्जाम में प्रॉब्लम पूछे जाते हैं. इट्स वेरी इंपॉर्टेंट चैप्टर एंड वन शुड टेक केयर. कोई भी एक्सटर्नल फोर्स नहीं लग रहा है एट पर्टिकुलर मोमेंट, इसकी वेलोसिटी जो है 20 मीटर्स पर सेकेंड है. ठीक है, अब वहां पर इस पर कोई एक्सटर्नल फोर्स नहीं लग रहा है. अब कितने डिस्टेंस पर जा करके इट विल स्टॉप, मतलब कि जब इसकी वेलोसिटी v 0 हो जाएगी तो डिस्टेंस मूव्ड कितना रहेगा वो निकालना है. ठीक है, इसमें थोड़ा सा हमने इक्वेशन ऑफ मोशन भी जोड़ दिया, राइट. 1D मोशन भी इसके साथ जोड़ दिया, फ्रिक्शन प्लस 1D मोशन. सी हाउ डज इट हैपन. Here we will find the frictional force is acting. So first we will find the frictional force. Here Fk is equal to mu k into r. Therefore Fk is, mu k is 0.1 and r is 8 into 10, that is 8 Newton. This much force, backward force is acting on this. मतलब क्या हो गया, ये इट इज मूविंग विद 20 मीटर्स पर सेकेंड. अब इसके ऊपर बैकवर्ड फोर्स लग रहा है, कांस्टेंट बैकवर्ड फोर्स. मींस जस्ट बिकॉज ऑफ दिस बैकवर्ड फोर्स देयर द रिटार्डेशन, नेगेटिव एक्सेलरेशन होगा इसके ऊपर, और नेगेटिव एक्सेलरेशन के कारण कुछ देर बाद जाकर रुक जाएगी. जैसा हमने बताया था, एक बाइसिकल आप पेडलिंग बंद कर दिया, देयर इज नो फोर्स एक्टिंग, एक्सटर्नल फोर्स. उसी तरह से नो एक्सटर्नल फोर्स इज एक्टिंग ऑन दिस. सो पेडलिंग बंद करने के बाद कांस्टेंट kinetic friction is acting, and finally it will stop and by traveling some distance. तो वो निकाल लेते हैं. Fk is acting, that is 8 Newton. तो इस पर रिटार्डेशन कितना है, अगेन इक्वेशन ऑफ मोशन. सो Fk is equal to m into a, retarding. This is retardation, right? Therefore 8 is equal to 8 into a, therefore a is equal to 1 meters per second square. इतने का रिटार्डेशन मिलेगा. इसमें एक वेलोसिटी है, फोर्स नहीं लग रहा है, सो दिस मच रिटार्डेशन विल बी देयर. अब ये रिटार्डेशन के साथ इनिशियल वेलोसिटी ये है, तो कितना डिस्टेंस चल के रुक जाएगा. तो वी कैन यूज इक्वेशन ऑफ मोशन, दैट इज v स्क्वायर इज इक्वल टू u स्क्वायर माइनस 2as. तो फाइनल वेलोसिटी इज 0, इनिशियल वेलोसिटी इज 20 मीटर्स पर सेकेंड स्क्वायर माइनस 2 into a into s. फाइनल वेलोसिटी 0. इट इज स्टॉपिंग आफ्टर ट्रेवलिंग. सपोज यहां तक आकर के ये रुक जाता है, सो दिस डिस्टेंस ट्रेवल्ड इज s. सो रिटार्डेशन इज 1 and s is the distance traveled. Therefore 2s is equal to 400 and s is equal to 400 by 2, that is 200 meters. So s is equal to 200 meters. So at a distance of 200 meters, this block will stop just because of this constant frictional force acting on it, and it is moving in this direction. When its velocity was 20 meters per second, no external force is acting, only frictional force is acting on it, due to which there is retardation, and this retardation causes this mass to stop by traveling a distance of 200 meters. So ऐसे हम बहुत से प्रॉब्लम्स अभी लेंगे आगे, and then I will meet you again. Till then, All the best. Take care of you.